Hello, welcome back to Mr. Algebra. For this video, we're going to talk about equations in two variables. Our first slide here shows the graph of an equation in two variables. It's a set of all solutions or ordered pairs that are plotted in a coordinate plane. So as you can see, we have a two variable equation right here, and the solution or this equation itself is actually plotted on the line right here. And each of the points that exist on that line, for example, this point right here, this point here, and any point along there, any kind of x and y along there, is a solution that makes this equation appear true. So if we take a look again at this first point, this point right here, that one is 2, 6. That's located at 2, 6. So in other words, if I put 2 here and a minus 6 there, that will equal a 4. As well, if I do this point here, which is 1, 5, that's this point here. If I put a 1 in for x, minus 5 for y, I still get a negative 4. But there's also an infinite amount of x and y ordered pairs that exist between each of these points, including decimal values, that still make this equation true. So that line basically represents the entire solution set. This is just another example. The difference in this case is we're using a much steeper line. You'll notice we changed the equation a little bit up here. We put times 2 for x, but if I pick any of the points that are on this graph, let's say I pick the one up here, which is 2, negative 6, and I were to substitute that in, 2 times x of 2 minus y was negative 6 equals 10. And don't forget that when you do this 2 times 2, you get a 4, but this minus a negative is really negative 1 times negative 6, which is a positive 6, and that equals 10. So you can see that that point does work. Let's suppose we choose a different point. Let's say we choose this one down here. This is in the negative for both x and y. So we end up with a negative 2 for x and a negative 14 for y. So we're going to go and substitute those back in. So 2 times negative 2 minus negative 14, and that should still equal a 10. So the first multiplication here is 2 times negative 2, which is negative 4. And we have a negative times negative, which is a positive 14. A lot of people overlook that. They leave this as a minus 14 here. And this becomes 10. And we can see that negative 4 plus 14 is 10. So 10 equals 10 means that that point also checks out. We want to be able to identify an equation as being linear or nonlinear. And one of the easiest ways on a graph is it will form a straight line. So that's what we have indicated here. Straight line. But if we're looking at the equation itself, there's a couple other ways we can tell as well. So basically we have two separate variables and they cannot be multiplied together. In other words, they can't be like x times y, or they can't be x divided by y, or you can't even have the variable itself in the denominator. So these are not allowed. Those are not linear relationships. But they have to have an x and a y. They have to have at least two variables separated. And another key component is that their exponents have to be equal to 1. If that's the case, then we are looking at a linear equation. So we look at our first example here, this one right here. We have x, which actually is to the first power, y, which is to the first power. So we have two variables, both to the first power. This one is linear. We look at our second equation here. We have y is to the first power. We have x to the second power, so that's not to the first power, so this means this is non-linear. Our next example, we have y to the first, x to the first, but you'll notice the x and the y's are not on the same side, and that's not part of the criteria that's necessary. They just have to be to the first power, so this one is also linear. And looking at this last one here, we do have a first power here, and we do have a first power here. But if you remember, we had some special cases over here, like this one right here, where it had 1 over x. Even though x was to the first power, you can't have your variable in the denominators. And likewise, you can't have your variable underneath a radical sign. This is a square root equation or square root function. So this is nonlinear. Next thing we want to be able to identify is whether an equation is a vertical line, a horizontal line, or neither, some kind of diagonal. So neither here really means some kind of diagonal. Diagonals are really easy to identify because diagonals will have two variables in them, and the two variables have non-zero coefficients. So this first one right here is a diagonal line. It's not vertical, it's not horizontal, it's neither. So some kind of diagonal line. This next example here has two variables. The coefficient of y is actually a 1. It's not a 0. And this one is a -4. So non-zero coefficients. This one is also diagonal. The next two down, you see they have only one variable each. One has an x, one has a y. One thing you want to do is probably just commit to memory that anytime you have an x value by itself like we do here, this one would be a vertical line. And the reason being is if we created a table of values, x and y, all of our x values have to be -4, -4, -4. So no matter what you put over here on the y side, you'll end up having a non-function creating a vertical line. In other words, it wouldn't pass the vertical line test. So x by itself is a vertical line. Y by itself would be the other one, which is a horizontal line. And we know that that's going to make a horizontal line, again, because if we make a table of values, in this case, the y value has to always be 10, because that's what it said. So no matter what we put over here on the x side, we'll end up with a line that goes across like this, which is horizontal. Now you do have to be careful on this last equation. Most people would want to call this neither, meaning diagonal of some sort. However, you'll notice that our x has a 0 coefficient. So that means there's really no x's because 0 times x is 0. So I could actually rewrite this as y equals 5. And since this has y equals 5 in there by itself, this right here would be horizontal line. One of the most basic things we do in algebra is graphing linear equations. And when we first learn how to graph them, it's typically from a table. So we have this equation right here. And all we're going to do is pick some input values. Remember, x is the input, it's the domain, it's the independent values. I'm going to pick some values for x, and I'm going to calculate the y value for each x that I put in. The first thing I'm going to do is look at this number out in front of x. If that's a fraction, which it's not, but if it was a fraction, I would choose numbers that are compatible, evenly divisible by whatever the denominator was. I don't have a fraction there, so I don't have a problem. So I can pick any variable or any value of x to make this graphing easy, so long as it fits on the graph. Now, one of the easiest things to choose for a variable or substituting a variable would be a 0. And I don't want my numbers to go too big, so I'm just going to pick a couple here. I'm going to go 0, 1, 2, 3, 4, and I believe 5 will fit on the graph as well. And all I'm going to do is take each one of these numbers. I'm going to start with a 0. I'm going to substitute it in right here for x. And so that first one would be 3 times 0 plus y equals 9. And 3 times 0 is 0. So I end up with y equaling 9. Then I'm going to come down to the number 1. And I'm also going to substitute it inside my x. So that next one will be 3 times 1 plus y equals 9. And then I just end up solving this for y. So I have to subtract 3 from both sides, and I can see that y ends up equaling 6. Then I'm going to substitute a 2 in. So I'm going to substitute a 2 in. 2 times 3 is 6. When I subtract it from 9, I end up with 3. And then I'm going to do the 3 now. 3 times 3 is 9. When I subtract it from the 9, I get 0. And then I'm going to put in the 4. And 4 times 3 is 12. When I subtract the 12 from 9 to get y, I get -3. And I put the 5 in there. 3 times 5 is 15. When I subtract it from 9, I get -6. Now, some people will start to notice a pattern going this way. As x goes up by 1, you'll notice that the y value is actually going down by 3. Now that's for a later video, but that is referring to slope. So I'm just going to go ahead and plot these points. And you'll notice that all those dots are actually lining up in a straight line. The only thing I got to do now is draw that line. And then I'm going to just kind of eyeball a line here the best I can. And there's my linear equation on a graph. Now you'll notice down here at the bottom, it does ask us to find the intercepts using a table. Well, intercepts are wherever the graph or the line crosses the x-axis or the y-axis. So if you look up here at the top, this line crosses the y-axis at -9. So that would be the y-intercept. And down here, the graph crosses the x-axis at +3. And that would be our x-intercept. Now, how do you recognize these from a table? Because on a graph, it's pretty obvious. You just look to see where it crosses the line. So what we look for is a 0 in the table, like those two zeros right there. Anytime our line has our table has a 0 for x, what you're looking at is the y-intercept. So this is the y-intercept right here. And the reason for that is if you look back up here at this point has the ordered pair of 0, 9. Actually, there's a mistake there. That should be +9, not -9. So 0, 9 is that location. So every time the line crosses the y-axis, the value of x has to be a 0. So look for zeros for x, and that will be your y-intercept. And then the reverse will be true for the x-intercepts. You look for zeros for y, like we see right here, and this becomes our y-intercept or x-intercept, which is 3. You'll see it's the same number that matches over here. Okay, so looking at a table is pretty easy to find the x and y intercepts. You're looking for zeros either in the x column or the y column, and the opposing side that has a number on it is the x or y intercept. On a graph, it's real easy also because it's wherever it crosses that line. To find the x and y intercepts from an equation, we have to go by these rules here. The x-intercept is the value of the equation when y is substituted with 0. And then vice versa, the y-intercept is the value of the equation when x is substituted with 0. So I'm going to go ahead and calculate this first one with an x-intercept. So the x-intercept occurs when we substitute a 0 in for y. So I put a 0 in for y. So I'm about to calculate the ordered pair, some number, comma, 0, which is going to be my x-intercept. Well, 3 times 0 is 0. All I'm left with is 4x equals 24. And then divide by 4, x equals 6. So my x-intercept is 6. Now if I want to find the y-intercept, I will have a 0, comma, some y value. So go back to my original equation, and in place of x, I put a 0, and then continue solving. This should be 24. So 4 times 0 is 0, which leaves me with 3y equals 24, and then divide by 3 on both sides, and y equals 8. So 0, 8. Now some people will start to realize that there's actually a little bit quicker way you can do this. If you take a look at the little box I have here in the center, this box will hide your x and your y's. So if I want to find the x-intercept, all I got to do is cover up my y, because putting a 0 there essentially drops from the problem. And the equation we see left over here is really 4x equals 24. You divide by 4 on both sides, you can see the x value, or the x-intercept, equals 6. If I want to find the y-intercept, I just slide my box over or cover up my x, leave the sign out in front of the 3. In this case it's a positive, so it's not a big deal, but if it was a negative, we'd have a problem there. And then I just solve for the y value, and y equals 8, and that's how you can quickly figure out your x and y intercepts without doing any work. I'm going to do that same thing over here on the right hand side. So I'm going to do the x and y intercepts. So the first thing I'm going to do is cover up y, which means I'm actually solving for the x-intercept. Now what confuses some people is when I cover that up, I actually have a 0 there, so you have to envision this is what your equation looks like. So that's basically 0. That box represents 0. So I have to first subtract 6 from one side, from both sides, sorry, subtract 6 from both sides, and I have a 2x equals negative 6 divided by 2, x equals negative 3, and those of you that are really good with your multiplication skills, you'll be able to do that in your head. Now if I want to find the y-intercept, all I got to do is cover up the 2x, and you'll see that this is y equals 6. Now if that was a minus 6 in front, it would be y equals negative 6, so my y-intercept is 6. Okay, the last thing we're going to do is graphing a linear equation using intercepts. So we're just going to use the x and the y-intercept to graph. Now you'll learn later on in geometry that it only takes 2 points to draw a straight line. So what I mean is if I have a point here and a point here, I can only draw one line between them. Or if I have a point here and I have a point here, I can only draw one line between them. Well, the x and y intercepts are 2 distinct points on a graph, so if you can find out where they are, you can use a straight edge and actually draw a straight line between them. Now the first thing I'm going to do is I'm going to calculate my x-intercept. Now I have my box there, but I'm going to do it the traditional way, which is actually substituting 0 in place of the variables. So to find my x-intercept, all I have to do is substitute a 0 in place of y. And 4 times 0 is 0. X minus 0 is an identity. That's just x equals 8. So my x-intercept is 0, or 8, 0, which is over here on the graph. And then I'm going to do the same thing with my x value. I'm going to put a 0 in for that and then solve for the y. So 0 minus 4y equals 8. Now I had the x-intercept here. Now I'm calculating the y-intercept. 0 minus 4y is still negative 4y equal to 8. And then I got to divide by negative 4 on both sides, and y equals negative 2. So the ordered pair there is actually 0, negative 2. And all I got to do is find a straight edge and then try and draw my straight line through there. And this is not going to be as straight as I'd want because I'm doing this on a tablet. But my line would look about like that.